Okay, so hi. Thank you for coming to my talk. There's a bit of an advisory here. Some of the stuff that I'm going to show, you might think like nobody's going to do that today. Like who would ever? But the reality is companies have been around for a bit, and some of this, like all of the stuff that I'm going to show here was caught in the wild. It's not theoretical. So once upon a time, we wrote our own code, like all of it. And we knew what was in it because we knew every little bit about it. So you might be thinking, like, who is this guy? My name is Luka Kladaric. I've been doing web stuff since around 1997 when I was a little kid. I was writing JavaScript before jQuery. I was doing server-side apps with old ASP with VBScript. Yuck. I ran away from that to PHP, I ran away from that to Python, and I recently ran away to DevOps. So today we know better than to code everything from scratch, but that means that we rely on frameworks and libraries and third-party code, and we outsource everything. We outsource authentication, we outsource logging, we outsource database interaction, API connectivity, like everything that isn't strictly tied to our unique scenario, to our unique problem, to our unique environment, we pull in other people's code and we use it. Now that's perfectly fine, but the problem that comes from not writing all of it means we don't have a very, very deep understanding of every like nook and cranny of that code. So this presents a documentation reading and thorough understanding problem, but also a lot of that stuff doesn't really have good documentation. So how does this problem actually manifest itself? Story time. So say you have example company and they build their first web app, and it's kind of like an internal control panel of some sort. So today you'd probably start off with some platform as a service or whatever, like Heroku. But if you're a company that's been around for like 5 or 6 or 7 years, you would have started with some sort of VPS or something like that. And back then, SSL certificates were more expensive. People didn't care about SSL that much, so you're just going to throw it on the web in plain text HTTP. So about authentication, it's an internal app, like who cares, whatever. We're a small team, we're like 3 people. Nobody's going to know that that's the URL or whatever. So you end up with either no authentication whatsoever. Just go to that URL and open the app and do whatever with it. This was like seen live. You end up with HTTP basic auth on Apache with a shared password that everyone in the company knows or has bookmarked. That password, once the company grows to 10 or 15 people, never ever changes again. So that you're stuck with that password forever because nobody could be bothered changing all of the things that interface with that app, like all of the cron jobs that call out to it, everything that has that password hard-coded. If you're lucky, someone said, hey, let's just dump all of our authentication woes onto Google and use Google Auth because like we're on Google Apps anyway. This is an internal app, like who cares? We're only gonna ever have like 30 users on this thing. So you're running an app that is protected by Google Auth on plain text HTTP. And then at some point you hire, like your stuff grows and your servers are no longer capable of handling the traffic themselves. You hire on some people that kind of know what they're doing. So they stick a load balancer in front of it, set up a couple of these machines, and now you're doing plain text HTTP load balancing. And everything's great. You're a tiny company. Nobody's ever heard of you. Nobody even knows your domain exists. Who cares, right? And then at some point, so maybe in this step, someone even asked about HTTPS, but you're like, no, wildcard certificates are so expensive, and we can't really host, we have just one IP. If we get a single domain certificate for a control dot, then we're going to want www dot, we're going to want like public app dot, whatever. So the problem everyone's aware that maybe you should be doing that, but you delay it. So at some point, someone's like, hey, guys, we should really do HTTPS. So what they do is like they implement HTTPS side by side like you do, and now you can access control dot as HTTP or HTTPS. And it's great, and then someone says, hey, like we should really like be redirecting this stuff and doing it properly. So on the load balancer, you say, okay, like we've had enough of the plain text stuff. All of our ancient clients and whatever have been migrated to support HTTPS. So let's just make a rule on the load balancer that when someone accesses our stuff with HTTP, we redirect it to HTTPS. Perfect. So if the servers, one thing here, the load balancer is the one doing SSL termination. The rest of it is behind, like the servers are no longer publicly accessible. So you're doing plain text HTTP to them. You trust that connection. That's fine. Almost everyone does it like that. Even like a few years ago, Google internally admitted to internally just using HTTP. Nobody encrypts internal traffic when you're on this level. So if the servers only ever see HTTP, how will they know that the connection was HTTPS? You might be wondering why, but we'll get to the why. But how will they know? And the spoiler alert, they won't. Not by default, anyway. So what would we like to see in terms of HTTP requests and transactions when someone goes to HTTP control.example.com? We'd like to see this, where the first, you can't see. So I've highlighted the HTTP with red and HTTPS with blue. Obviously, that doesn't show well enough. So the first request is to HTTP. Server big IP means the big ass F5 load balancer caught it and was like, no, you need to go to HTTPS. And he redirects you to HTTPS, that same URL. You get to your Flask app, whatever. All of this stuff is applicable across all languages and all frameworks. It's just tiny differences. So your Flask app gets a request to the home page, and it's like, no, all of my requests actually need to be authenticated, so please go to the login page. The login page goes, yeah, but we don't actually do local username and password, so please go to Google and log in there. And when you come back from Google, please come back over HTTPS to this page, so control.example.com/login/authorized. So here, this is one request, and you get bounced around a bit. The user logs in at Google or was already logged in and grants the access to your app. And then Google's servers, the GSC, redirects you back to your app on HTTPS/login/authorized query string code equals access token. Because your app could be fully internal and Google cannot have access to it, we've mostly standardized on this approach where all of the secure stuff is mostly in band. So Google is trusting the user to tell you their token, and then you can verify the token with Google directly, because Google is publicly accessible. What actually happens? This. So you go over HTTP, because that's what you bookmarked ages ago. You get redirected to HTTPS. Flask goes, yeah, but you need to log in, but it sends you to HTTP. When Flask has to construct its own URL, it can't tell that you came over HTTPS. So it goes like, yeah, I'm on HTTP, my host name, which I know, HTTP, which is the default, and the URL I want you at. And then it redirects you, and then the load balancer is like, whoa there, what are you doing? You need to go back to HTTPS. And then you load the page, and then you hit the login page on Flask, and Flask goes, yeah, you need to go to Google and log in there. But the redirect URL is HTTP, because again, Flask doesn't know that you loaded the page over HTTPS, and it's not configured to do anything else by default. User logs in and grants the access to the Google account, and then sends you back to HTTP control.example.com. Now, the load balancer is going to catch this and redirect you to HTTPS again. But at this point, it doesn't matter. You've sent a request unencrypted over public internet with your access token. And at that point, if you're on hotel Wi-Fi, if you're at a security conference, if you're at a Starbucks, someone can catch that and they know your access token. And at that point, they can just send that same request as you, preferably before you, and redeem that token for full access to your app as you. So Why does this happen? It happens because if you're self-hosting an app on a server, the server tells the application, hey, this is HTTPS. There's standard protocols for that. Most applications have been built to deal with how Apache tells you that, how Nginx tells you that, and so on and so on. But when you take the SSL termination and move it to the load balancer, that breaks, that just the web server is unaware that it's HTTPS. So what do we do? The load balancers, most of the time, like this, the big IP, the F5 is standard issue hardware, and almost an almost standardized approach is that we set the X forwarded proto header to the value HTTPS. So this is a non-standard header, non-HTTP standard header, which says I've forwarded this request to you, and the original request was SSL. The reason why we don't treat it why we don't respect it out of the box is a weird edge case. I keep flip-flopping between it's actually exploitable and not really. So I'm not really sure. I'm not sure, like each framework, some of them treat it automatically. Flask for sure doesn't. So another thing is you have to watch out for various components treating security headers differently. So in that example where we had just one box, if we had SSL on it and we wanted to enforce it, so the thing that our load balancer did, there's a very simple Flask plugin that's called SSLify that will take any HTTP request and bounce it back. And that works, even in these scenarios. If you had that and you didn't have the redirect rule on the load balancer, your Flask app would do that. And why does that work? Why does that not result in an endless loop? Because the SSLify code looks at the header, while Flask proper core doesn't. So you have Flask and you have the plugin, and they have different ideas of what an SSL request is. And this could happen in any part of your stack. So you could have part of the stack that thinks that they're on SSL and part that doesn't. SSL config changes should trigger an audit. Somebody at some point added SSL to the load balancer, added the redirect header, and didn't bother checking whether all of the apps respected it, whether they handled it properly. Maybe they loaded the front page and saw the redirect to HTTPS and like, we're good, we're golden, who cares? But that's not how that stuff works. Any change that could potentially affect the security of the app needs to trigger a full audit of how the app actually behaves in the wild. Another thing is that you saw that the callback is passed in as HTTP. That stuff is whitelisted explicitly on Google. So Google has a list of acceptable callbacks, and HTTP was whitelisted there. If you remove that, even with all of the stuff that is broken on your config, Google would go, nah, I'm not going to do that. And the most important part of this is HSTS headers. HSTS stands for HTTP Strict Transport Security. It's a header that can only be sent over SSL, but once it's set, you can. It comes with a time value where you say, for this duration of time, which could be like 1 year or whatever, do not ever attempt to contact me over HTTP, and silently rewrite any HTTP request to HTTPS. If someone, even with the broken setup, if someone had done that on the F5, like any request that comes over HTTPS, when you return it, set HSTS, that means the first time someone loads the app over the broken setup, as soon as they're bounced to HTTPS, they would be like their browser would fall back to default to HTTPS for the foreseeable future. Now, this isn't a full fix in terms of if you have this broken setup where you can even access it over HTTP, and you're dealing with a fresh client and they've never contacted you over HTTPS, you can still like man in the middle that and blah blah blah. But HSTS combined with the callback being whitelisted only on HTTPS would have solved this entirely. This stuff is very difficult to catch because all of this bouncing around, browsers don't report this as bad behavior. Hopefully this will change at some point where if you're looking at a site on HTTPS and you get redirected back to HTTP, that's going to be a red flag. It used to be back when HTTPS was very rare, but recently it's normal behavior for browsers. Okay, that's story one. Story two. So we have this stack. We have our internet. We have our load balancer that bounces any HTTP back to HTTPS. It's registered to control.example.com, and we have our web servers that are not publicly accessible that are serving that application. But really, it's never one application. Everyone thinks like we're going to build the app. It's going to be the one app, and we're never going to build anything else. And then it's like, hey, can we build this stats dashboard? Can we build like an FAQ thing where you can manage your FAQs? Whatever. So it ends up being a bunch of apps on a single IP, and they all have the same problem. If you've ever set up OAuth, so logging in with Facebook, Twitter, Google, LinkedIn, whatever, for multiple apps at the same company. So you have one app, suddenly you have two apps, and you're all logging in, and like all of the apps are going to the same provider. Did you bother setting up separate OAuth clients? Or are they all using the same client secrets and everything to like sign the request and so on? Yeah. So in this example, all of the apps use, like, to Google, they're the same app. The requests come in digitally signed the same way, and the tokens that Google returns can be used by any of the apps because it's the same app. So that means that if someone were to catch that access token for an insignificant app, they could use that to log into your critical app that has customer data, that has, credit card transactions, whatever. So I've seen this a lot. I've done it. Don't do this. Don't be lazy. Set up separate OAuth clients to ensure that access keys cannot be reused between apps, because nobody cares. Like, the users will never care, and it's very exploitable. Even without the whole SSL thing, it's possible to intercept stuff. Like, people are willing to accept broken SSL certificates on airports and hotels and so on. People will click through man-in-the-middle attacks, and they'll be like, this is an insignificant app. This is like the internal company directory with phone numbers. Who cares if someone sniffs that? But someone steals that token, uses it somewhere else. That was the second story. Third story is, what are cookies? What are sessions? When I started doing websites, first of all, there were no sessions. And there were sessions where we were like, session ID 42, please. That time is long gone, and now we have this encrypted mess. And how is that encrypted? How does that even come to be? Well, how is cookie signed? For Flask, a well-known Python framework, you have a configuration value which is called secret key. You set it, and then it uses that to encrypt and sign and whatever various things, among others, the sessions and stuff. It says it defaults to none, but it'll warn you about that, and you can make it like not work with that. Same with Django. It defaults to empty string, but it'll refuse to start if it's an empty string. Okay, so it's not possible to actually use this with no secret key defined. But so going from this example where we have one app running on one server, and this example where we have 4, 5, 10 apps running on various different servers. So one thing that session key, it doesn't hold just the session ID. Because with this distributed web server architecture, we can't really afford to store the data somewhere else and then just send them the session key and then go and fetch the data. We actually cram the small parts of crucial data in the session and then we encrypt it. So in this example, you have various different apps. What if the secret key is the same between them? What if someone steals your session cookie? If you're using Google Auth on all of the apps and someone steals your session cookie, they can literally go to the other app and replay it and get access. So the key being the same is incredibly difficult to catch because the data that is being encrypted is different across apps. It has the same keys in the hash, but it's different. So you're never going to see the same values coming from two apps. What you might see are like really weird situations where you're logged into one app and you go over to another app and you're still logged in despite never having logged in there like in the last 2 weeks, but it's kind of broken, like some stuff is missing. You will see your name in the like header is missing, or you'll see your profile photo missing. I've like stuff like that. And there was an example where I was seeing this behavior for weeks and I couldn't figure out what it was. Like, how am I even logged in here? It's a different host name. And it's kind of broken where you have to log out and log back in, but and then you go back to the other app, but you don't do it the same day. The next day you go to the other app and you're like, I'm just logged in here, but it's kind of broken. So you could even have multiple versions of the same app. So in this example, even though you have like 3 different apps, maybe the apps have unique keys, unique secret keys, but control, you don't, so not control, but like if you have a public app, something that users actually use, you don't want every commit going out to them because you don't want to break it for them. So you're going to have like, say control was a public app, you're going to have control. You're going to have control-dev, which is like rolled out immediately. You're going to have control-demo for if you're showing it to prospective clients and you don't want to use the real app with the real data. You're going to have a separate database for the demo and so on. But the secret key is going to be tied to the control app and not to the specific instance. This is the result of developers knowing what secret key is and what it does and what the implications are. And sysadmins setting up this whole deploy system and like various servers and Ansible and whatnot and not understanding what it is. And it's like, yeah, secret key, sure, make it unique for the control app, whatever. And then once you have control, the developers come over and is like, hey, can we have control be frozen in time and have automatic deployments go to control-dev? Sure, let's just copy paste the same configuration block and it's going to be the same secret key because it's the control app, who cares? We end up having people authorized to one app being able to go to, so an attacker might sniff a key, the session stuff for the demo app, which has demo data and nobody cares, and you treat it less securely, and they can replay that same session against the real control app. So all of these combined together. So this was caught over like several different places, several different companies, several different apps. But if you were to put them together, it's a spear phishing vector. Say you were attacking a company that has millions of dollars in investment, they're about to go big, they're your competitor, you really don't want them to go big, you really don't want them to succeed, and you know where their office is because it's on their website. It says that and that address in like San Francisco or whatever. If you stalk the Starbucks and various like cafes around it, all of the shitty places that have shitty Wi-Fi, you can probably sniff something, it's like a part of this, and that gives you a shoo-in. Like privilege escalation between different apps, between stuff like that, forced insecure comms. So without HSTS, without all of that stuff, if you catch someone accessing an app over HTTP, you can just say, okay, you go and do it over HTTPS, satisfy the servers, and then you serve back the content over HTTP. You have a plain text connection. You don't need to fake any certificates, nothing like that. They're perfectly happy being on HTTP. They're probably not going to even notice. So And in this case, because the person that you're attacking is in the same Starbucks as you, you're there, they're there, the traffic between you two is indistinguishable. There's no chance of catching this happening because you're the only one accessing and you're proxying everything that they do. You could spoof their user agent, you could spoof all of their cookies, everything. And the important thing here is the load balancer isn't the one to blame. Like all of this could happen without that. All of this misconfiguration and so on could be used even if it was a single server running SSL on it without HSDS, without all that stuff. People have ancient bookmarks pointing to HTTP. You're not gonna have everyone delete every bookmark ever. You're not gonna have everyone type in HTTPS control.example.com. They're gonna access it over HTTP. What you need to do is make sure that they cannot do that once you know that they're your user, they can never access you over HTTP again. And as soon as you've established secure communication, make sure that it stays secure. So all things being equal, but running on a single machine, this would still be a vulnerable setup. Like there's no doubt about it. HSTS is absolutely a must. Like there's no discussion here. If you do HTTPS, and there's no reason for you to still support HTTP, HSTS, entire domain, on everything. Do it on the load balancer. Make sure every single request is tagged with it. Story 4. CSRF protection disabled. Does everyone know what CSRF is? Cross-site request forgery is an attack where a user goes to site 1, and site 1 causes their browser to make a request on site 2 in a way that causes site 2 to think that the user clicked a thing on site 2. So it's a long time ago, there was an attack on Amazon where CSRF was used, there was an attack against users where CSRF was used to buy a bunch of books from some author, earn them a bunch of money. If you were logged into Amazon, had one-click enable, you'd visit some random site and, hey, you've bought a book. I've seen CSRF disabled in production this year. Legacy apps, like people don't even know that it's there. And the worst part of it is, once an application grows to a certain size, there's absolutely no chance of a new developer walking into it, doing an audit of all of the configuration. They're going to trust that the setup that they're used to, the Flask, the Django, the whatever, is set up properly out of the box. And like Django offers you forms functionality that just does CSRF automatically. If you use Django forms, it just tags requests with the CSRF token. Everything is secure, everything is golden. But if someone went and disabled it, you don't know. Like your app works exactly the same, your code looks exactly the same. You need to know to look for it. And in 2016, I didn't know to look for it. I was randomly doing something completely different in the config files, and I saw CSRF enabled equals false, 2016. It comes with the thing, leave CSRF protection alone. Don't touch it, don't disable it. The takeaways here are, understand the stuff you use better. The time when you knew everything because you wrote everything is long gone, and we need to focus on understanding the tool set that we use. Don't pull in 300 dependencies for your stuff. If you can find things that cover larger blocks of functionality that you need, use that. I'm not saying don't pull in anything, but manage your dependencies and know what they do, know how they work, know their edge cases, and so on. Be more vigilant with code reviews on security impacting stuff. Any change to web server or load balancer configuration, any change in how SSL works, any addition to these redirects and so on needs to be, like, the apps themselves need to be audited. You need to look at the requests, you need to see what they do. And bring in a fresh pair of eyes every once in a while. Half of this stuff I caught doing consulting for companies on something else. They would bring me in because they had performance issues. I would say, okay, we need to split this app up. You have, these two things running in the same app, and this is getting a ton of traffic, and you want the 3 requests a day to be high priority. We're going to split it up, and it's completely separate functionality. We're going to split it up. Oh, hey, this app I need to set up OAuth for it, and hey, there's a bunch of HTTP whitelisted apps there, and they're all like, they're all under the same client. I need to set up a new client. So bringing in fresh pairs of eyes to look at your established stuff can be extremely helpful in digging up these issues that have been there for months or years. This talk is not an endorsement to roll everything yourself. That's not what this is. Third-party open source code that has been vetted, that has been audited and analyzed by other people is great. You're never going to achieve that level of security on general purpose stuff like authentication, API stuff. No. Bring in external code as long as it's open source, as long as it's maintained, as long as it's up to date. If hundreds of people have contributed to it, that's great. Thank you. Any questions?
Yeah, the question is, I totally agree with what you said regarding not knowing what you are doing by using too many different libraries and stuff.
Okay.
Everyone is important. Whatever, how low you go, still you are using some libraries. But the question is, for me as a networking security / encryption guy, it's interesting to see point of view of application guy. From my point of view, SSL, TLS does not have to be connected to HTTPS. And still all the time we are talking about this, that we have problems that we can roll back from HTTPS to HTTP. But if you are really putting SSL termination device in front of your web server, and there is no such possibility. And another question is, in case that you are running, let's say, known users, and a relatively small number of them, why wouldn't you use client certificate for authentication? Because that way you will avoid a lot of troubles with different people connecting to your site.
Okay. So the question is, let me see if I get this right. Question number one is, why are we talking about falling back to HTTP at all? Why is that still a thing? And question two is, why not use client certificates? I'm going to address client certificates. Those are ridiculously difficult to implement if you're a tiny 3-person company trying to raise your first $100,000. Like if 3 people are living in the same apartment, coding every single day, trying to ship something and show it, they're not going to get around to client certificates. They only got around to SSL like 2 years ago. That's one. As far as falling back to HTTP, to plain text, it's a very unique thing about HTTP, which is unlike any other protocol that we use. So HTTP is, as far as I know, one of the only protocols that supports virtual hosts in the way that it does, where you could have wildly different results based on which host header you send. SMTP kind of has that. And second, HTTP is one of the only protocols that I'm aware of that lets you link to other stuff. So I'm trying to think of a protocol that would tell you go to this other resource. I can't really think of anything. So the fact that HTTP has the ability to redirect you somewhere else means that HTTP has to be self-aware. SMTP servers don't care how you got to them. It's just IP. Any other protocol that I can think of is just you go to the IP, you speak the protocol, that's it, MySQL, whatever, databases, caches, none of it has host headers. HTTP is self-aware, so it needs a way to refer back to itself. This stuff is just, so the first part where Flask redirects to HTTP itself, that's just broken because it could have just said redirect to / whatever. It could have omitted the protocol and the host name entirely. I don't know why it doesn't. But the part where Flask tells Google the callback, that's Flask needs to know what protocol it's on, it needs to know everything. The fix for the xproto header whatever thing is you enable a line in Flask and it becomes aware of it. We fixed it there by making the web server actually the web server aware of the header that the load balancer sends and tell the app. But the app, at the end of the day, web apps, if they're interfacing with external APIs and doing callbacks and redirecting users, they need to be aware of their host name and their protocol. And yes, if you're doing SSL, you could configure you could hard code. You could say this app is only ever running on SSL, never ever attempt to do anything else. But then you hit the fact that people develop this on their own machines. They don't have SSL certificates for localhost. You can work around that, but it's a pain. It's an unnecessary pain for doing development. You could say, have a wildcard certificate on some random domain that is routed to localhost. All of it is solvable. Let's Encrypt, a recent project. When did Let's Encrypt become usable? Recently. This is stuff that has been around for a few years and stuff that I caught in the last 2 years. So there are solutions. None of this is an unsolvable problem. I didn't come here to cry about unsolvable problems, but all of them raise the bar to entry. They complicate things just enough that people are willing to look the other way and just, we'll deal with that later. It happens all the time. And all of it is very, very solvable if you care about security more than you care about raising your first round of money.
Regarding your first story and dropping to HTTP, don't new browsers nowadays warn you about redirecting and dropping SSL? Or is that only within the same domain you drop SSL?
They don't even do that anymore, I think. I'm not...
I remember seeing warnings, you're exiting SSL connection.
Once upon a time, when SSL was rare. So once upon a time, you didn't have SSL on every single domain. You had secure.yourdomain.com, and you had an SSL certificate on that, and it was a completely different site. There wasn't an HTTP secure dot. That was the secure place, that was the secure forms and whatever, and resources, all of the JavaScripts, and so on. And back then, when you went from secure dot, when you went from HTTPS secure dot to something else, the browser would go, hey, you're about to leave the secure site. It's become so prevalent that sites send you to HTTPS and so on that no longer happens. I don't remember the last time a browser stopped me from navigating from HTTPS to HTTP. I think recently browsers are starting to flag. So it used to be that HTTP was the okay, HTTPS with proper certificates was the secure, and then HTTPS with self-signed certificates with expired certificates was like the broken lock thing. Google Chrome recently announced, I think, that they will start flagging HTTP requests as unsecure. So the UI itself is going to reflect it. But this stuff, I saw this, the redirection this year on multiple browsers. I captured the traffic, no warnings. Okay, thank you.